Highest points and the lowest points, exactly. So if you identify the highest points and the lowest points, if your highest here, if your highest here, and your highest here, what's the important thing that happens at those highest and lowest points? What's the important thing that happens? What does the derivative equal there? Say it so humans can hear everybody, not just like supersonic animals. What? 0, right. So what should we label? Where should we mark some points for the derivative? On the what axis? On the x-axis. So we go straight down and we label it here, here, and here. So I'll get rid of those right now. So we now have 3 points for our derivative right there. 3 points for our derivative. What's the next thing we should analyze? What's the next thing we should analyze or look at if we want to figure out some more about the derivative? Maybe we should identify where the function is increasing. So if I labeled these 3 points, let's say this one's A, B, and C. Can someone tell me one place where it's increasing? Where's one place where this function is increasing? Can someone tell me where it's increasing? You've done this many times. Okay, everybody stand up. Let's move around a little. Let's get you woken up here. Connor, where is it increasing? From negative infinity to A, right. So it's increasing here, right there, if I could actually highlight pretty well, which I'm having trouble with. Where else is it increasing? Eliana, what?
B to C.
Yeah, B to C. So where is it decreasing? A to B and? So that's where it's decreasing, that's where it's increasing. So where it's increasing, the derivative is what? Positive or negative?
Positive.
Positive. So it's going to fall to here. And it's also, then what's it going to do once it gets to A? Is it going to cross below the axis or go straight back up? It's going to go below because the slope becomes negative. So it's going to go down and then up. And then what's it going to do? Up and then down and then down. How many turning points does that derivative have? How many turning points does the function have? 3. It's going to go one less. Okay, sit down. Way to warm up. The way to sound so excited. Hey, 1. Now, you're looking for smooth curves here. You're looking for smooth curves. Now, there's an interesting correlation here that you've hopefully noticed, and we've talked about a little bit, is this lowest point, where does this point, let's call this one D, and where does this point, let's say E, have to correlate to? Where should this connect to? Or what should it correlate to? What should it be across from? This is the most negative slope, right? So that should be directly under where the function is most negative in its slope of the tangent line. So maybe that's where it's most negative right there, right? So that point E looks like it's maybe a little off. Do you see why it looks like it's a little off? Because where does it look like let's erase this section right here. So again, this was increasing right here. Where does it look like it's steepest? It looks like it's steepest like right there. So it should turn around at that steepest point. So maybe like this, something like that. Like that. There we go. Nice. Very cool. Does that make sense, everybody? Okay, so we're warming back up. We're re-remembering some of the things you had to do. What was the last question on the test? It asked you to do something. Find this. What's the easier thing to find, the point or the slope? The point. Point's easier to find. Now, if you're trying to find the slope, do you want to have to use the limit definition? Not really. So instead, what are you going to use? The shortcut. So do that for me right now. Find me the equation of the tangent line at x equals 2 of that. First, find the what of that function right there, the derivative. So y prime is going to be, can someone just tell me what it is? Yep. Plus 6x?
Minus 6x.
Minus 6x plus 5. So you want to do y prime at what x value? 2. So you get 12 times 4 minus 6 times 2 plus what? So you end up with 48 minus 12 plus 5. I think that's going to be, what, 41? Mm-hmm. So that's the slope. So you have y minus 22 is equal to 41 times x minus 2.
What is dy?
Ah, that's a great, great question. In calculus especially, but in many places in math, there are many symbols that mean the same thing. This means the derivative of the function y in terms of x. So that means derivative. That's another way to say the derivative of. So that's the same thing as f prime of x or y prime of x or delta y over delta x. It's all the same. There's lots of different notation for derivatives. There's lots of different, and they're just interchangeable. They're just interchangeable. Some of them are a little bit more useful in some circumstances than others. But if it says find dy dx, all that means, Nick, is find the derivative. That's all it means. That's all it means. Version of the calculator you have, but either way, you're going to do this. You're first going to enter in the function as y1. So what was that function? It was 2x plus 4, so parentheses, 2x plus 4, and then what was it divided by, can anybody tell me? What is it, 3x squared plus 2? 3x squared, like that, plus 2. So that's the first thing you do right there. You put the function in your calculator. We've done that a bunch already. So then we're going to quit out to the main screen. I'm going to clear the screen here. Now, the next button is going to be in the same place for all of your calculators, but when I press it, it might look a little different. You're going to go into math, and did you see the 8th option? It says nDeriv. You're going to hit 8 or go down and hit enter, and I get something that looks like this. I get something that looks like this, and this is what you enter in if it looks like this. You're going to put an x in there, and then you put in, what function do we want to take the derivative of? y1, and then we want to know what the derivative is at 2. That is, take the derivative of y1, d over dx means take the derivative of, remember what was that notation you pulled up for dy dx, right? There it is, dy dx. There it is. And what are we taking this means evaluate, that bar means evaluate at x equals 2. So theoretically, when I hit derivative, what's it going to give me? It's going to give me the derivative at x equals 2. Is it giving me the derivative function? It is not giving me the derivative function, but that's what it looks like on my calculator. This is really important. Could it look different on yours? And this is what it's going to look like on some of yours. Don't do it yet, but I'm going to show you what it looks like on yours if you do it out a little bit different, if your calculator most likely will say something like this. Instead, when you hit, after you put in y1, you're going to hit nDeriv, and it's going to literally say on your calculator, nDeriv with an open parentheses. Then what you're going to do is y1 comma x comma 2. That means take the derivative of this function in terms of that variable. Now we're doing single variable calculus, so what's the variable always going to be called when we're using our calculator? This is always going to be x, and this is the number you're evaluating it at. In a way, this is easier to enter in. You don't have to press any arrow keys. This is just more of a natural way. It's called math print. I can update your calculators to look like this, but it's not super important. So try this now. Enter in the function, and it's going to look like this one or this one. And then see if you can get the same thing I did. See if you can get the same thing I did. Or what is it? Y at what? 2? What do you get? 4 plus 4 over 3 times 4 plus 2. So what is that? 8 over 14. So that's, hey, it is 4/7. So if that's the slope right over there, and that's the y coordinate, can someone tell me what the equation of the line is? Can someone just rattle it off for me? Y minus what?
Y minus 4/7.
Y minus 4/7, yep, equals?
0.347.
Yeah, negative 0.347 times x minus 2. So what we could do, how could we visually check to see if that's correct? What could we do with that equation? How could we visually check? Graph it, exactly. So what I'm going to do here, I'm going to show you one other thing. On the y equals, I'm graphing the function and the derivative, right? Do you see how the equal signs are highlighted, everybody? If you go over to the equal sign and press enter, it turns off that graph. So I'm going to turn it off there. So if I want to enter this function into the calculator, what's the only thing I have to do to enter that into the calculator? I have to move one thing. Put it in slope intercept, or just get rid of that negative 4/7 on that side. So what I can do instead is make it y equals negative 0.347 times x minus 2 plus what? Can you enter that into your calculator? Yes, absolutely. So we go back to the calculator and we enter in, what is it? Negative 0.3347, right? Times x minus 2. Is that right? Nope. Plus 4/7. Do we have to simplify that at all? Does the calculator care? So let's graph this and see what happens. So we should see the blue one. The blue one comes up. And then what should we theoretically see come up right now? What should we should see a red line, or black in this case, because it's the third one. Oh, does it look like it's tangent at x equals 2? Does it touch once at x equals 2? Yeah, the scale is 2 there. It's not just 1. Does that make sense, everybody? So does that visually verify? Mm-hmm. That visually verifies it. So we could change potentially. It's not 5 anymore. What else might change?
So it's going to be to the east instead of...
I'm not asking what, yeah, so what are the other things that could potentially, the 5 could change? What else could change? The number of feet, right? And the direction. That's the only thing that's going to change. So the 5 is going to turn into a 10. And then, so what happens now? It turns into a 10. Did anybody get the, for 10? Anybody do 10? Yeah. What is it? Right here, we have the equation and the derivative, right? We have the equation and the derivative. I'll just clip this in just so you can remember what it's supposed to look like when you're doing this on your own. But it looks like this right here. Exciting. I know it's super exciting. You're like, I can't believe it's so exciting. Okay. So what I'd like you to do now is go back to your original